In this class, I am going to discuss about Boolean algebra. In 1854, George Boole invented or introduced Boolean algebra. Boolean algebra defines constant, variable, and functions to describe binary systems. It describes a number of theorems that can be used to manipulate logical expressions. Boolean operations are the codes for two basic logic gates. Okay. So Boolean variables A to Z, Boolean constant 0 or 1, and possible combinations of n variable to the power of n. Okay. So Boolean algebra, so combination of variables, constants, and the number of combinations of the variable. For example, I am taking three variables. How many combinations? 2 to the power of 3 equal to 8 combinations. So that will give us the number of combinations. Next. So difference between Boolean algebra or algebra and binary numbers. Okay. So I'll discuss directly with an example. You can see here. So Boolean addition, okay, normal decimal addition, and it is a binary addition. Okay, na? So binary addition means 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 0 carry 1. So binary addition 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, and 1, 1, 0 carry 1. This is a binary addition. Okay, na? Next, decimal addition. Decimal means normal numbers. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 2. And this is the Boolean addition, means logical addition, logical functions. So this plus is nothing but OR operator, logical OR operator. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, nothing but 1. Because when both inputs are high, so logical operations, no, when both inputs are high, output is high. Okay, this is a logical OR operation. Okay, no? This is addition. This is a Boolean addition. Okay, no? Decimal addition, and it is a binary addition. Okay, now we are going to see some Boolean laws. Okay, na? Boolean laws. There are completely different laws are there. We'll discuss one by one. First, Boolean laws. First one is what? Cumulative property. First property of the Boolean law is what? Cumulative property. Here, A plus B equal to B plus A. First, I am adding A with the B. Okay, na? Then I am adding A with the B. This 20 minutes. A plus B equal to B plus A. Okay, na? First I am adding A with the B or B with the A. Okay, output will be the same. And A into B equal to B into A. For example, A I am taking 0, B I am taking 1. Okay, na? I am taking 0, B I am taking 1. So substitute here 0, A is 0, no? B is 1. And B is 1 plus A is 0. A is 0, B is 1. I am substituting in this equation. Okay, now. So A is 0, B is 1. So 0 plus 1, 1 equal to 1. So we got same thing, no? For example, A is 0, B is 1 equal to B is 1, A is 0. 0 into 0, 0, and 0 into 0. So like this we should verify. So substitute the zeros or ones into that, and you can verify. Okay. Next, second one we are going to talk about. This is a cumulative property. A plus B equal to B plus A into B equal to B into A. Next, associate property. So cumulative property will work on only two variables, and associate property can work on three variables. So A plus B plus C equal to A plus B plus C, and A into B into C equal to A into B into C. For example, I am writing first A plus B plus C. First I am adding these two, and the result I am adding with the C, that is equal to A plus B plus C. First I am adding B plus C, the result I am adding to the A, we will get the same answer. Okay, na? Similarly, A into B into C equal to A into B. First I am multiplying A into B, then after the result I am multiplying with the C. Here first I am multiplying B into C, the result I am multiplying with the A. Okay, na? This is very important, right? So associate property and cumulative property completed. Now we are going to talk about De Morgan's law. It is very important. What is De Morgan's law? Okay, na? So A plus B whole bar equal to A bar into B bar A into B whole bar equal to A bar plus B bar. For example, look at here, A plus B whole bar equal to A bar into B bar, and A into B whole bar equal to A bar plus B bar. Okay, na? So I'll give one how you are going to easily remember this. I'll tell you. Okay. Okay. Look at here. First, you write here A B equal to A B. Here also write A B equal to A B. So for example, here writing plus here, write into here. If you are writing into here, write plus here. And we are writing whole bar here. Here separate bars. Here whole bar here. It's not a separate bars. So same thing, no? A plus B whole bar equal to A bar into B bar. A into B whole bar equal to A bar plus B bar. Okay, no? So in this way we should remember. Okay. Next, distribution property. Okay, na? So here distribution property nothing but A plus BC equal to, okay, na? First you should, so that is the answer, A plus B into A plus C. Okay, na? So this is a distribution property. Look at here. First A plus B, I wrote A plus B into A plus C. Okay, na? A plus B into A plus C. Okay, na? Similarly, A into B plus C equal to, so A into B plus A into C. So this is a distribution property. Okay, next we are going to see axioms of Boolean algebra. Axioms means conditions. Okay, na? So axioms means conditions. Axioms of Boolean algebra. So A plus 1 equal to 1, A into 0 equal to 0. See, A plus 1 equal to 1. See, if you are adding 1 to the any variable, so output is always 1. For example, I am writing B plus 1 equal to 1, C plus 1 equal to 1. Take any variable, if you are adding 1 to the any variable, the output is only 1, because for example I am substituting here A plus 1 equal to 1. Suppose take A equal to 0, substitute 0 plus 1 equal to 1. Okay, na? So if you take A equal to 1, A equal to 1, okay, na? So A is 0 substituted. Now I am getting A equal to 1, right? Now, so 1 plus 1. So 1 plus 1 is 1 only, because it is a logical operator, right? If any both inputs are high, output is high. 1 plus 1 equal to 1. Okay, na? What I mean to say that if you add 1 to the variable A, which A may be 0 or 1, so output is always 1. So A into 0 equal to 0. So 0 is any variable value must be multiplied with 0, no? Output 0 only. Okay, na? Next, A plus 0 equal to A. A into 1 equal to A only. Okay, na? A plus A equal to A only, not 2A. A plus A equal to A only. Okay, na? These are some standard formulas. So A into A equal to A only, not A square. Okay, na? So because 1 plus 1 equal to 1 only. If you substitute A equal 0, 0 plus 0 equal to 0. 0 nothing but A, no? So like that, you should remember. Okay. So these are some laws. And next one is what? A double bar. Okay, na? Next one is what? A, so bar complement both. So these two will get cancelled. Output is A. Okay. So this is some axioms of Boolean algebra. Okay, next we are going to see about A into A plus B equal to A plus AB equal to A only. Okay, just substitute A equal to 0 or 1, you will get the same answer. Very important, A plus A bar equal to 1, A into A bar equal to 0. Okay, na? A plus A bar equal to 1. For example, look at here. a plus a bar equal to 1. So substitute a equal to 0. So a equal to 0. 0 bar means 1, no? So we can 1 only. For example, substitute a equal to 0. A equal to 1. A bar means 0. Sir, not a bar means 0. How we are going to get 1 only? Okay, na? So a plus a bar is always equal to 1. A into a bar always equal to 0. So these are the axioms of Boolean algebra. Okay.